Okay. All right. So number 4 on the back of this thing. So remember, we do have our pictures down here. We're going to be referring to those a couple times, right? So we have how to calculate wet salt. We're going to be taking the B minus A, right? Dry salt and then water, right? So hydrate, anhydrate, and water, okay? All right, so you have your data up here. So very similar to what you have in your lab, all right? It says for the first part, calculate the mass of the anhydrous magnesium sulfate. And it does tell you on your lab page itself that you're going to be subtracting D minus A, right? So we're going to go ahead and have, in this example, 45.56, and I'm going to subtract A from that. So it's in your best interest to copy this down or at least watch very intently so that you know what you're going to do on your lab. All right, so I'm going to subtract those two. And we're going to get 1.2 grams, okay? All right, letter B. So this is the anhydrate, okay? So this is your dry. Letter B says calculate the moles of the anhydrous magnesium sulfate. So this is your MgSO4, and this one is converting it to moles. So when we had to convert to moles in the past, that's your other notes page where we were learning about all of our conversions. It's dimensional analysis. We're going to start with what we've got. So I have my 1.2 grams of magnesium sulfate, right? I'm going to bring grams down to the right, and I'm going to have moles on top. This is where we have our guaranteed 1, and this is where we put our molar mass. So I'm going to look and figure out what magnesium sulfate is. So my people who happen to have magnesium sulfate, what was your number? 120? What was it? 120 what? Yes, okay. 120.367. Sounds great. Okay. Okay. So at this point, now what we're doing, we have 1.2 times 1, and then divide by that 120.367. So I got the answer 0.0099, and I'll round up to 7. Okay. And yes, I would write that many decimal places. Does it look pretty? No, but you're fine. Just write it for now. Okay. All right. So we have that many moles of magnesium sulfate. All right, so the mass of the water driven off from the hydrate. So mass of water means that we're going to take our wet salt minus our dry salt. So I'm going to go ahead and have B minus C. Okay, so I'm going to have 46.79 minus 40. Oh, I should have done minus D. Sorry. 45.56. Okay, so I got 1.23 grams of water. So now I'm going to convert that to moles. Okay, so I'm going to start with what I have, 1.23 grams. Bring my words down to the right, convert to moles. So that's my 1 mole is equal to the molar mass of water. Molar mass of water, what is it? Yep, 18.02 grams. Okay, so 2 hydrogens plus an oxygen. All right, so we have 1.23 times 1, push equals, divide by 18.02. I'm going to get the answer 0.068. I'm going to go to 6. There we go. Okay. I'm trying to keep it pretty similar. All right. So we have that many moles of water. Okay. So this right here. It says this is the equation that occurred in order for us to do that, right? So we had our hydrate. We heated it up. You don't have to write this part if you don't want to. We heated it up, and it left us with our anhydrate plus water. That's what this thing is saying, right? That's what the little equation is saying. Which, by the way, side note, on your lab paper, I'm so sorry, my people who had copper sulfate. I did not type that one correctly. You should just make sure you go through and cross out and put Cu if you had the copper sulfate. I'm so sorry I didn't update that, okay? All right. If you didn't have blue, don't worry about it. All right, so that's our little equation. So the whole point of this lab was that we were trying to figure out what N was. We're trying to see if we could get it, okay? Now, I will just say when I ran the lab, I had a 20% error, and I ended up having that like off by 2, all right? So there's a really good chance our data is not going to work out well for that, but you'll actually get to see that percentage, which is going to be a nice, it'll be a nice number for you, okay? So just roll with it for now. Follow the instructions along the way. All right, so if that's what we have, then that means that our mole, we're talking about this mole of this to that, right? So our moles was 0.00997 moles of MgSO4 to 0.06826 moles of water. So it's just saying this is my ratio, all right? This is my ratio. This is my conversion factor, or my conversion that you're going to use in the next question, okay? All right, so now we're trying to figure out if we want to have 1 mole of magnesium sulfate, then what is water going to be? All right, that's the part that it's actually asking you for, okay? So we're going to start with, I'm going to write over here because I just have more room. I'm going to start with 1 mole of this MgSO4. I'm going to bring words down to the right. Okay, I'm going to change into moles of water. And now this is our conversion factor. That's where that's going to get used. Okay, so I'm just going to match this up. So I'm going to have the 0.00997 on the bottom and the 0.06826 on the top. And we're going to get an answer here. Okay, so I'm going to multiply across the top. And then I'm going to divide by the bottom. And I got the answer 6.84. Okay, so that's what my calculator said. On your lab page, it tells you that you have to round it, because when we've been balancing in the past, would we ever have 6.84 in front of something when you were balancing? No, we always had to have whole numbers, all right? And the whole point of this, and even our hydrates, never did we have a decimal in any of our examples, right? They were all these whole numbers. So we have to make that be a whole number. We're going to see that again tomorrow or later for empirical formula. So what whole number would you round that to? A 7. Okay, you would round that to a 7. So that tells me that our magnesium sulfate was MgSO4 7H2O. That's what my data is saying. Okay, that's what our data told us, 7H2O. So that's where yours might be a 7, might be a 5, might be a 4. It just depends where your stuff is at. Okay, all right. So the next part is calculating the percent water in the hydrate. That is our experimental value. So our experimental percent comes from the data table. Okay, so from the data table. So we want water divided by hydrate, or water divided by our wet salt, right? And then multiply by 100. So My water value, we have already solved for up here, which was 1.23 grams. My hydrate, I hadn't solved for yet. So that one came from, if I want wet salt, we had B minus A, right, at the beginning. So B minus A would be 46.79 minus 44.36. So 2.43. Okay? So with those two, I type them in and then multiply by 100. I got 50.62%. This is my experimental value. This is my accepted value. And if you take a look at your lab paper, I gave you all of the accepted values that you would need. So if you had magnesium sulfate, I gave you that one. If you had copper sulfate, I gave you that one. So this next step is just percent error. Okay, now I'm just going to use the version that's on your lab sheet as well. So percent error. So percent error, you want to have a low number. Just heads up, okay? So me getting 20%, I was like, that's not great. But we had 50% earlier and things like that. So don't worry. This is a tough one to get very accurate, especially with moisture in the air. All right, so experimental, I had 50.62. My accepted is 51.1. I'm going to subtract those first, or put parentheses around them, and then divide by 51.1, and then multiply that answer by 100 to get a percent, okay? And then that's it. So if you do it like that, and I'm getting a negative 0.93 for our purposes, we're doing absolute values, which I think is what I put on your lab paper. All right, so when I did this, I got 0.94% error, which is amazing. So I guarantee we're probably not going to have that, but all good. That right there is the calculation. All right, so you're doing, and I really do try to walk you through each of those on the lab sheet as well, but at least you'll have something that you can refer to kind of just check to see where did we pull this number from, where did this one come from. All right, so I'm going to give you guys about five minutes to kind of get yourself somewhat going on it, just to make sure you don't have any questions, and then we will probably pull up the empirical notes as long as everybody is working. Okay, all right.